Okay, in this second video, I'm going to go through the questions after the definitions. So make sure you have a calculator to follow me and you can type this in on your own because watching me do it is a little bit different. So number one, what is the gravitational force between Earth and the Moon? So those are going to be our two masses. So Earth's mass 5.98 times 10 to the 24th. Make sure you have this on your note card in addition to the radius. And then, so that's M1. M2, the moon's mass. Oh, look at those typos. That's annoying. And then the distance between them, or my R value, is 384. Be careful here how many zeros. 1, 2, 3, 4, 5, 6 zeros. 2, 3, 4, 5, 6. So from here, I just need to plug it into my equation. Don't forget big G, and don't forget parentheses, because if you don't use parentheses, oops, that's supposed to be a 2. You will not get the correct answer. And then 1, 2, 3, 4, 5, 6, and then that number gets squared. It's super easy to forget the squared of the radius. So remember, I'm just using the number one equation of our unit, the only one. So from here, we just have to type in. So I just wanted to make sure that G is stored in the calculator, and then G times parenthesis times. Now that is divided by 384, 1, 2, 3, 4, 5, 6 squared. So my answer here is that the force between these is 1.988 times 10 to the 20th. Remember, E equals times 10 to the something, to the exponent. And so if I was typing this number into Quest or into Canvas, I would type in 1.988E20. That's the number I would type. E can be capital or lowercase. So now how would that gravity change if Earth had double the mass? We did a lot of these kind of what if scenarios. So if M was twice as big, so is F. Remember though, when we change, so it's going up, when we change the radius or the distance, it's going to go down. When things get farther apart, there's less gravity. And so there's always still gravity, but there's less. So it's going to go down, and it's changing by 3 times. But the radius is squared. So the 3 is getting squared. And so it's going to go down by 9, or 1/9 the original, getting smaller. Okay. Number 3, at its closest point to the sun, what is the distance between Pluto and the sun? So I'm solving for distance. If the force between them is 898 times 10 to this 22nd. Mass of the sun and mass of Pluto. So in thinking about this, this is the closest point to the sun. So if here's the sun, okay, here's the other focus. Obviously, this isn't perfectly accurate, but it's talking about right here, if that's Pluto. Now, that distance obviously changes if Pluto's way over here, but we're talking about the closest point. So what's that distance? Well, let's write out our equation. Remember that when we're solving for r, it's going to be a little tricky because it's squared and it's on the bottom. So I'm just going to plug in my numbers. Have to plug them in carefully and with parentheses. So it's a bit messy. I want to turn this whole thing into a number that is more recognizable. That's less messy. So here's my one mass, second mass. So that big number is going to be that big number. So I'll just kind of, well, I'm going to leave that for now actually. At this point, remember we can cross multiply, butterfly, or we can just times r squared to both sides. Whichever we do, oh yeah, no worries. Whichever we do, we're still gonna get the same response. So if I cross multiply, I get this number times r squared equals this number, and that's this one on my calculator. So I'm going to write that. Wow, that's big. At this point, I need to divide both sides by this with parentheses. That crosses out, and then that leaves r squared alone by itself on one side and a number. So here I'm going to go divided by, so it's giving me the answer from before. Oops. $1.9, I'm going to round 4 times 10 to the 19th. So now I need to square root. Then once I square root on the calculator, I can use second answer. So it's using the number from before. That is my final answer. I'm going to change it into scientific notation, but you could just write the whole thing. But I'm going to say 4.4 times 10. Let's see how many to the 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a positive 9 because it's such a big number, and that's meters. That'd be my final answer for the closest distance between Pluto and the Sun. Is the question above the largest or smallest force between the Sun and Pluto? Well, if Pluto is at its closest distance, when distance is smaller, force of gravity is biggest. So this is the largest force, and make sure that you understand that why, because we have a small r, and so in our equation we're dividing by a smaller number. We're gonna get a bigger response. So at that point, would Pluto be traveling with a fast or slow? Fast. So if force is maximized, that leads to a bigger velocity. And remember from the lab, you should have some responses like that in this part here when you were looking at this simulation. That when the planet was closest to its sun, all of a sudden it went really fast and whipped around, and the force arrow got big and the velocity arrow got big, and then it slowed down when it was farther away. In comparison to Earth, compare Pluto's orbit based on the following metrics. Rate smaller or bigger than Earth. So to help us, we can use this chart here. So we're thinking about Earth, and Pluto's not on there. but Pluto's on here, so that'll help us. So in comparison to Earth, well, here it says that Pluto's eccentricity is much bigger. So it's bigger, meaning it's more oval than Earth's orbit. Now, if we added Pluto to this chart, Pluto would be added at the very bottom here because Pluto is the farthest away from the sun. It's really far. And so if Pluto is very far away from the sun, it's going to have a really big semi-major axis because its orbit is very large, very elongated. As a result of that, the period is going to be big too. Or we could say it's long. Like Neptune, it takes 163 years for Neptune to go all the way around the sun one time, which is pretty crazy. The last question and thing you should feel good about for our test next week is about Kepler's laws, and not just from the lab. You do want to understand how the lab words them, but you also want to be able to explain them in your own words. And for these ones, you should see your lab document or Canvas practice test. There's also on Canvas great videos about Kepler's laws, short ones, in the assignment on the class log where you found all of the simulation links when you actually did the lab.